Good morning, everyone.
Let's go.
Well, thank everyone for coming out today. I'm Ryan Siegel. I'm here with my coworkers, Cassie Carroll and Sean Maurer. We're here from Smart Energy Design Assistance Center at the University of Illinois, Urbana-Champaign. How many of you are familiar with SEDAC? A few of you, okay. Did want to make sure that everyone got various handouts that we do have today. One of which I know it says success with the 2015 Illinois Energy Code. There's a lot of good detailing in there. So even though it's, we are now moving to the 2018 code, most of the information in there is still valid even on the 2018 cycle for good building practice. So there's just a couple of little changes in there. Some of the values, like the U value for Windows, has changed slightly, which we'll talk a little bit about today. But that's some good material. We also do have the International Energy Conservation Code books here, as well as the presentation slides for today. So is anyone missing any of those? Okay. All right. So to give a little bit of background about us, as I noted, we are housed at the University of Illinois. We are part of a public-private partnership with 360 Energy Group, whose office is out of Chicago. And our primary mission is to reduce the energy footprint of the state of Illinois. So that's both public sector and private sector, which that's part of where this training today comes in to play. We are the state of Illinois training provider for the Illinois Energy Code, and this is sponsored through the State Energy Office, formerly with the Department of Commerce and Economic Opportunity, or DCEO. That office has moved over to the Illinois EPA. So a little bit of a transition that happened here somewhat just in the last couple of years. We are here to provide assistance for you building owners, design professionals. We're here to assist with technical assistance for anything dealing with the state of Illinois or a project here in the state of Illinois. So we answer questions from all over the country, as far away as Nebraska and Vermont so far. So as far as ways to get a hold of us, we do have an 800 number. However, probably the more easy way to get a hold of us is through our email address, energycode@sedac.org. We also do have several available online resources. We do archive our workshops as well as webinars that we give. Our webinars are typically sort of a lunchtime during the noon hour. So for people who might not be able to get away, those are available. And we also have online on-demand training. So these are, right now there's a set of 4 modules out there. We're going to be launching a few more here in the near future. And these are designed to be an hour, maybe an hour and a half long. They are targeted more at people who are less familiar with the Energy Code. So a little bit more of a beginner's style module, some of which, like the residential module, may be useful for a homeowner. As far as, okay, why am I being required to adhere to this Energy Code? What is it? What's the benefit to me? Because most people don't necessarily understand that complying with the Energy Code leads to a lot of other benefits, such as increased comfort. We understand that people frequently don't necessarily pay as close attention to their energy bills, but they do notice if they're uncomfortable or not. So this is a look at our Energy Code website here. Energy Code is up in the right-hand corner there. And then on the left-hand side of the web page is where we have our different archived workshops and trainings, as well as frequently asked questions that we have. this frequently asked questions, we are going to be transitioning from the 2015 to 2018 code cycle for those. This is also where we publish any updates as well as links for the Illinois Energy Code. So these links would also link not only to the International Energy Conservation Code, but also Illinois amendments, as well as the City of Chicago amendments for it. So, one of the big questions that we've been having as of late is, when is this effective? For the City of Chicago, they implemented the 2018 version of the code as of June 1st of this year, and today is the final permit day for the state of Illinois for the 2015 version. So permits beginning Monday are now on the 2018 version, regardless of where they are in the state. So, as far as codes themselves, these are adopted predominantly at the local level, some at the state level, and we'll talk a little bit about which ones are adopted by the state of Illinois. And then it's up to the localities to deal with enforcement of this. So the Energy Code is one of many building codes. We'll see here in a little bit. A lot of the other ones deal with fire, electrical, structural, plumbing, accessibility, and the like. So energy codes are a little different than appliance standards. They are very related to one another, but there is some overlap, particularly in the HVAC side. Typically, the product standards will end up driving the energy code as far as what's available on the market, what is cost effective and feasible. And then the International Energy Conservation Code is one of several codes available. And these are model codes, where these are designed on a national level through various boards and committees to develop these model codes that can then be adopted in whole, in part, or amended by localities, or localities may decide to develop their own code completely. We have seen a trend away from locally developed codes in using more and more model codes. One of the biggest changes that happened this year is the City of Chicago did away with their Chicago Building Code, and they moved to the model code with amendments, but they had moved away from developing their own code. Predominantly, that's just a real cost driver, because it is very labor intense to develop and maintain your own codes. As noted, these are developed on a national basis, and then it's up to state and localities to adopt codes for their area, and then enforcement here is done at the local level. As far as how the codes are developed, these are predominantly done on 3-year cycles, whether this is through the energy codes, National Electric Code, among several others. These are done on 3-year cycles, and the International Code Council develops codes for adoption, and ASHRAE develops standards for adoption. So little minor nuance there, but a lot of overlap. Now, as far as the International Code Council, they are somewhat new to the picture, only 25 years old now. And so they were kind of driving behind, developing these national standards that could then be adopted rather than every state and every jurisdiction trying to develop their own. So I noted most codes are adopted on a local level. However, there are a few codes that are adopted on a state level. So something interesting that we did find is this is as reported to the state of Illinois by municipalities as far as which code versions they are on. And something interesting is here you can see that 2012 is a hump in 2006. So this is kind of a bell curve with the exception of 2009 in the middle. And so what it appears to be is cities have kind of adopted it as they went along. However, 2009 municipalities have not really necessarily wanted to jump to. So either cities have moved past it into the 2012 and 2015, or they stopped at the 2006 and haven't progressed further. So, Illinois adopts a handful of codes for the state of Illinois, and this is regardless of where you are in the state. So this is the Energy Conservation Code, Plumbing Code, and Accessibility Code, as well as the Life Safety Code by the State Fire Marshal. Right now we're at the 2000 version. The State Fire Marshal is in the process of moving to the 2015 Life Safety Code. So that'll be quite a change here in the near future when that takes effect. Capital Development Board, the link here on the bottom, they maintain a record as far as municipalities and what building codes they are on. And this is the record as held by the state of Illinois. And so here we notice that this municipality is sitting at about the 2003 code versions they have. Some of them do have local amendments, some do not. Something we have noticed, and perhaps we'll be working with the CDD as far as trying to help clean some of this, is the official records shows 2003 version, but when I went to this municipality's website the other day, I saw that they're actually on the 2006 version. So they have moved to a more current code, but the state hasn't been updated of that change. Also, we've seen several that are using some of these uniform building codes and BOCA national codes. Those have been published in over 20 years now. Now, what may be occurring, and what we have seen in some of the design world, is the design professionals have moved to a more current and more modern code, even if the jurisdiction hasn't adopted it. Presumably, this is partially for just consistency of, I don't want to have to try to maintain records of 30-year-old codes, and some is just liability. Some of the codes that we see on the state records go back to the 70s and even some of the 60s. So it may be that the municipality has updated it, but they haven't updated the state as far as what the current version is. So, as far as the state of Illinois is concerned, this is the official list. Frequently, what we do find is permit applications are fairly simple and straightforward. Not a whole lot of information here. Some of these do have some opportunities for something that this may not have been updated fairly recently. And so, as code officials, it's not uncommon where some of the usability becomes harder and harder as years go on, particularly with the adoption of the Energy Conservation Code. And we'll talk a little bit here and show you some examples as far as what some other municipalities have used that makes it a little easier for code officials for review, as well as design professionals as far as did I make sure that I got all of the boxes that I needed to. Illinois, for municipalities that had not adopted local codes as of 2011, adopted statewide codes for commercial construction. And these are the default codes for the state of Illinois as of today. Is 2006 International Building Code, Existing Building Code, Property Maintenance Code, and the 2008 National Electric Code. So the state is looking at perhaps updating this to a more current standard, because being that 2011 is now 8 years ago, so we're now 2, almost 3 code cycles from that point. Now, as far as which code they might move to, that's not really known at this point. But they're looking at saying it's probably time to move to a little bit more current as far as the default code. As noted, Illinois Plumbing Code and Energy Conservation Code are adopted for the whole state as well. These are only the defaults for municipalities that have not adopted a local code. So one problem that we have seen is municipalities, such as the one that I'm from, has the 2005 National Electric Code as their standard. So if I'm inside my city, I have to go on the 2005 version. Once I step outside the bounds of my city, I have to move to a more current version of 2008. So there's definitely some challenges with that. As far as how codes are adopted here in the state of Illinois, Capital Development Board reviews and adopts the most current version within 1 year of the first printing, and then it becomes effective 6 months later. So now that we've finally made it through this process, the new date is July 1st, is the effective date of the 2018 code. And as noted earlier, Chicago moved June 1st. They just looked at it and said, I can't keep waiting. Originally in the state of Illinois, we were looking at a March 1st, then it was an April 1st, and now they finally, it's finally made it through, and it's officially July 1st. Anyone here deal with state-funded facilities? Community colleges, universities, Department of Corrections, any number of different things. Big change coming here is state facilities will now have the same options as the rest of the state. Previously, state-funded facilities were required to use ASHRAE 90.1. They will now be allowed to use the IECC for compliance. So, again, trying to standardize and help everyone play by the same set of rules. That's a big change, because now they have the same options as everyone else. We see typically most people using IECC for compliance rather than 90.1. Do you guys have the same experience? You see most people using IECC? Mostly? Okay. So that's a big change for a lot of people. With that, I'll turn it over to Sean to talk about as far as why do we look at the energy codes and why they're important.
One of the big reasons the energy codes are important, building consumption in the U.S., 39–40% is in buildings. Energy code is trying to bring that energy usage down. This is a breakdown of building energy consumption. 35% is commercial, 37% residential, 27% industrial uses. So this is where our energy code is trying to target these facilities and bring down that energy consumption. This chart shows an index for the various energy codes. The top is residential, the bottom is commercial. The arrows on this chart show when Illinois adopted their codes. The index on the side is 100 kBTUs per square foot per year, and then each code revision is a reduction. You can think of it as a percent reduction or in terms of the index. As you can see, when Illinois adopted their residential code here,
Chicago is purple.
That's right. When the state adopted their residential code, it was right after a significant change. And then a year after they adopted, there's another big change. There's a lot of heartache over the codes being adopted on the residential side from there. On the commercial side, their jumps are a little less significant. That's why implementation is kind of lagging behind a little bit in the state as far as implementing the codes. Because there was a very significant change in what you had to design buildings for, energy-wise, insulation-wise. Another thing, we took a survey of state energy code enforcement officials. This survey might look a little bit different for people that are actually designing codes. We asked what is hampering the code from being implemented. And the big response we got was a lack of understanding of the code. And some other things were lack of clarity from state jurisdictions. Obviously, having multiple different codes and multiple different municipalities contributes to that. So that's part of what this training is trying to address, is get people familiar with the code, and get people to understand why the code is important, what additional benefits the code has on top of just improving energy consumption, reducing energy consumption. Code enforcement is the duty of local officials to enforce minimum compliance documentation. Most of the time, there are different processes for that. Trying to remember the different documentation processes. There's the prescriptive code method. There are online resources that you can model performance based.
Yeah, res
check and com check. And again, using those to meet the code, there's a lack of knowledge in how to use those programs, how those programs work in regards to the code, what they're referencing within the codes themselves. Lack of consistent enforcement. Different code officials interpret the code differently. So if you work with one person, even in the same municipality, someone else might have a different interpretation of that code, which is why on our website we have a way for people to email us and ask us questions and interpretation assistance. That's the energy codes at SEDAC.org. This chart looking at the question of so 69 code officials were part of this questionnaire. We're asking of the number of buildings getting permitted, how many people were responding back as far as who's implementing the code. So the more buildings that were being permitted, the more people were trying to follow the code, the fewer buildings. Getting into permit requirements, for additions, alterations to buildings, new construction. That's when the code is actually needing to be enforced. If you're not changing a part of an existing facility, that part of the building doesn't need to be brought up to code. So this is part of the code to deal with making changes to existing buildings, alterations, things like that. So an alteration to an existing building is defined as alteration to the existing building system or portion thereof shall conform to the provision of the code. So if you're changing ductwork, if you're swapping out a piece of HVAC equipment, if you're peeling off a roof, putting new insulation underneath, those changes need to be brought up to the current code level. If you're doing a repair or slight change to a building where you're not opening up a cavity, you're not changing the actual component of the building itself, those don't need to be brought up to the code level. So, for example, we had a question recently about masonry walls. The person was adding furring strips and putting plaster on the inside of that wall and was asking if that needed to be brought up to current code levels of insulation. Since there's no building wall cavity there that's being opened up, that wall could be left as is, didn't need to be brought up to full current code level of insulation. How does the code impact facilities? On the residential side, ventilation and ductwork is part of the code. Lighting systems, HVAC and water heating are part of the systems part of that code. Fenestration, air sealing, insulation are all part of the envelope section of the code. The residential section is a little bit simpler than the commercial code. When you look at the commercial code, water heating is broken out from HVAC systems due to the additional complexity of having circulating systems and larger networks of piping. But otherwise, the sections of the code are about the same. You've got an HVAC section, you've got an envelope section that deals with air sealing, insulation, windows, section for ductwork and ventilation requirements, and a section for lighting and electrical power requirements. Access to the code, the IECC is very nice, has online access. It's searchable. The ASHRAE 90.1 also has a website that you can access for free, the energy code on it, but their search function is not quite as nice as is with the IECC version. The IECC version opens up, it's got a table of contents. You can text searches within it so you can find exactly what you're looking for. We actually use that a lot in our office when people send us questions. Instead of trying to hunt through and page through the book, go to the web page, search the keywords in their question, figure out what they're asking, and go right to the sections of the code that we're looking for. One of the big questions we get is, especially in mixed-use facilities, is this going to be a residential code facility or is it going to be a commercial code facility? The definition of a residential facility within the code is a detached one-family or two-family dwelling or any building 3 stories or less. In Chicago, it's 4 stories or less. That it's used primarily for permanent occupancy. If you've got a mixed-use building where one floor is, the ground floor has got commercial and the upper 2 floors are residential, the ground floor section would have to meet commercial code within the individual spaces, but the envelope of the building, the residential section, that would all meet residential code. That would be under the residential provisions because it's a primarily residential facility. Once you get into larger facilities above 4 stories, then you're looking at a commercial facility, even if it is like a multifamily residence. So here's some questions. You've got a 5-story mixed-use building, 2 stories of it are retail stores, and 3 stories are apartments, and it's in Chicago. Is that going to be a commercial facility or a residential facility? Commercial. You got a 3-story mixed-use building with 1 story of retail stores and 2 stories of apartments in Carbondale. Is that residential or commercial?
Residential.
Residential. 5-story single-family home. That's actually tricky because it's a single-family home. This is going to be under residential. And a 3-story hotel. That's going to be commercial. That's because it's not permanent occupancy, it's transient occupancy. You can see it gets a little tricky sometimes. Compliance paths for meeting the energy code, ASHRAE 90.1 2016, or now the 2018 IECC. In the 2019 IECC, you've got a prescriptive compliance path where the code book spells out specific requirements for equipment that needs to go in, R values for insulation, or U value path method. Or you can do a building modeling performance path method. That performance path to build a model and has to do certain percentage, 50?
It's a certain target.
It's a target reduction below the model design following a prescriptive path. Residential is very similar. When you're using ResCheck, it's using the UA trade-off path down here. CompCheck is also kind of following UA trade-offs for envelope requirements. It's important to know those when you're using that program and it's using a specific compliance path to check things. If you're designing a building to the prescriptive requirements and you plug that into CompCheck, you might get a failing report even though you followed all the parts of the code because it's using a different compliance path to determine whether you're meeting the code or not. The ERI, Energy Rating Index, the 2018 code has actually made it a little easier to meet that. They increased the rating index from 50s to 64.
mainly to get people in the residential industry to start using that as a means to meet the code, and also as a way to, you can display that energy rating index when you're selling a house or something. It's a good way to market that the house is an energy efficient facility, and that you also get the benefits from building an energy efficient facility, like improved indoor comfort, longer durability of equipment, and the facility of the house itself. Climate zones for the state of Illinois, where you're climate zone 4 if you're down south, climate zone 5 if you're up north. If you're following the ASHRAE code, it's a little bit different. There are 6 counties right there on the border that are actually part of climate zone 4 if you're following the ASHRAE compliance path. If you're following IECC, that's the different climate zones for the state. And that impacts primarily insulation requirements in the code. There's a slight difference in some of the HVAC requirements, but it's primarily fenestration and insulation requirements that your climate zone will determine. Prescriptive components of the code, they're component specific, so specific R value of insulation, specific U value, specific piece of equipment has to have a specific efficiency rating. That's prescriptive parts of the code. So if you're following a prescriptive path, or if you're following a mandatory path that has a prescriptive note to it. Mandatory requirements are required and cannot be traded down. So if you're looking at lighting, for example, some of the paths allow you to trade off lighting in one space so you can increase lighting power density in another. That's an example of a tradable thing. If you're following a mandatory requirement, those can't be traded off. They have to be met per what's written in the code, even in the simulated performance paths. Primarily that impacts ventilation rates and some of your HVAC equipment. Some of your trade-offs have hard limits where you can't trade off, like you can't have a no wall insulation in an R100 roof. It wouldn't be a very effective building. Residential compliance options, res check is kind of the recommended and quick and easy path. Once again, that follows the UA trade-off method instead of the prescriptive R value method for envelope. You can also follow the prescriptive method, simulated performance method, or the energy rating index requirements for the code. For the commercial compliance options, once again, ComCheck is the recommended compliance path. It's a relatively simple and straightforward program to use. You enter in your U values, you enter in your equipment, it checks it all against the code to make sure it meets. Again, it's important to realize that it follows a specific UA trade-off path and not the prescriptive path for envelope requirements. But you can also follow a prescriptive path for simple HVAC systems, so there's a prescriptive path for complex HVAC systems, total performance method, where you have to do better than a model building by a certain percentage, and with ASHRAE 90.1 prescriptive path. ASHRAE tends to not be followed very much by the state. People tend to lean towards the IECC, primarily because ASHRAE has a lot more requirements on the electrical side for occupancy control and things like that the IECC does not include at this time. Some significant changes to the code. At this current code cycle between 2015 and 2018, there's not an expected to be a large difference in energy consumption for the buildings. A lot of this code's revision was moving things around, making the code easier to follow. There were some slight changes. Mechanical sections reorganized so that all equipment types and systems are in one place. You're not having to hunt through bouncing between different sections of the mechanical section of the code to figure out where your requirements are. There are some additional efficiency packages added, including enhanced envelope performance and reduced air infiltration. Those efficiency packages, if you're following the prescriptive path, there are a series of different efficiency packages that you can add to your buildings. You have to select a couple of them to meet the code. So this gives you a couple more options for how to do that. And then there's more detailed requirements for controls of buildings. and the wording of that was changed from BAS systems have to be capable of doing something to they'll be configured to do something. What they were finding with a lot of buildings is they would be set up with a domain control ventilation system or able to do something like that, but it wouldn't be enabled in the building, so it wouldn't actually saving them any energy. It was just capable of saving them energy. So they changed the wording in the code to make that actually state that those things have to be working when they're installed. The solar ready zone has been added to the 2018 IECC. California reference there, and reference to Action 90.1. Note again that there's a difference between the climate zone maps for those two different versions between the IECC and ASHRAE. Primarily affects people kind of in that closer to southern Illinois. Probably not as much of an issue up here in northern Illinois. And there's new additions to the performance-based compliance tab in Appendix G. On the residential side, there's not expected to be any difference in the reduction in energy between here and the 2015 IECC. There was a definition added for the word approved. That was changed from
Based on testing.
Based on testing. And then inspections. Change from construction work shall remain accessible and exposed to visible and able to be accessed for inspection for checking insulation levels. This is in reference to having insulation in place. Sometimes we have to build in a building component that makes that covers up part of that insulation, makes it harder to access. So this is just making sure that all those areas of the building are able to be checked before they're covered up. Now I'll hand it back to Ryan. He'll go over the details of the commercial section of the code.
Before I dive in here too far, a couple of slides back here. So these are references provided by the City of Chicago as far as part of their permitting process. I noted earlier that some municipalities may want to update some of their permitting process as far as making it a little easier for compliance. You notice here on the residential portion, not only does it ask which compliance path are you taking, which, you know, as a code official, when I go to do a set of plan review, I need to know which path you're going through so I know what to look for. You know, if you say that you're going to follow the energy rating index, I know I'm going to be looking for some sort of a REM rate or something along the HERS rating line. I know to be looking for that performance printout and documentation. And so having that compliance method identified up front makes it a lot easier for me. Something else they also did is with residential, because you tend to see a little less in the design professional side in involvement, is they make sure to include, here's all the mandatory provisions that you have to comply with regardless of which box you checked up here. So having this list outlined, it's real easy for the home builder or whoever to go through and check off, yes, got that, got that, got that. You know, even things such as, did you make sure to seal your ductwork? So there's several provisions here that are mandatory. As Sean talked about, a lot of the 2018 code is looking at more usability. And so one of those was previously most everything in the mechanical systems was a mandatory provision because I think it was something along the lines of C403.1 was mandatory and said, oh, make sure you follow, 403 2 through 13. Well, they hadn't marked 2 through 13 mandatory, so they were seeing a lot of issues where those were being missed because they called out that it's mandatory up here, but forgot to designate on all the rest of them. So in the 2018 version, as you go through the mechanical systems, you'll see a lot more mandatory, 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 mandatory. It wasn't so much that they changed it, it was they went ahead and referenced it all the way through, rather than only putting it in the first reference. So, as far as the commercial side, Sean mentioned there are some additional energy efficiency packages. This is for the prescriptive requirements. It says you need to do all of the prescriptive things and choose one of these, formerly 6 items, now up to 8 items. So again, trying to give a little bit more design flexibility as far as how do you want to meet the code? Because different buildings in different regions will have different opportunities for improvement. One project may say, oh, it's a lot easier for me to go ahead and pick off some additional lighting and make my lighting more efficient. Another site, they might say, well, it's easier for me to have better HVAC. And so the code is providing a little bit more of that flexibility as far as how do you want to comply. We want to get the building energy down. You can kind of choose how you want to get there. You know, I just need to make sure that I arrive at my destination. There's several different ways to get to any location. So, 2 of these, the last 2 that were added, you notice enhanced envelope performance and reduced area infiltration. As Sean noted earlier, there were some drastic changes on residential performance a few years ago. A lot of that had to do with the building envelope performance. That was when the residential envelope, they tightened up that requirement as far as how much your envelope was allowed to leak, and they said, you're going to test it. It's not uncommon where you see, you do what is measured, and so once they said, oh, you're going to test that, oh, you're serious about this, okay. It wasn't just, yeah, I got to build it good. Yeah, it was good. How do I know you built it well? You test it. So these last 2, enhanced envelope performance, and in 8, reduced air infiltration. Reduced air infiltration for commercial is done, you have to pressure test that envelope. Very similar to the residential side, much larger scale. As far as the enhanced envelope performance, this says you got to have 15% better insulation value. Again, this is looking at the total UA. So this is where that ComCheck can come in handy as far as it's doing that UA performance test and check. This is a document out of Canada. Canada has done a whole lot of building science research. And so this is a good document talking about thermal bridging and even going through how do you take what might be typical, might be poor or regular performance, and how do I make it better? Those details really matter. One of the biggest things they focus on is thermal bridging. Thermal bridging can be real problematic, particularly in commercial, where we have metal building members and concrete to materials that are really not very good insulators. And so here we've got a typical building wall section, and you can see I've got R12 on the outside of the building with some Z channel, and then an R20 back inside. But I have metal framing members. And so when I, up here you say, okay, I've got an R32, almost 33 in there. But once I take into account the metal framing members, it's actually only an R14.3. There is a table here in the code book that actually calls this out as far as for metal framing members, what is the spacing and the depth of the cavity and how much insulation, and it gives you what the effective R value is of that. And it's something on the order of 2/3 of the insulation value is gone. So and here again, you've got an R33 down to an R14. So 2/3 of the insulation value is kind of pointless in this. So this is where thermal bridging really plays a role, and the code has been encouraging and moving towards more continuous insulation, eliminating that thermal bridge. Because, again, that thermal bridge eliminates 2/3 of my benefit. So an R5 on the outside really provides, an R5 continuous is a real big benefit. Here's an example of thermal bridging. SEDAC had been called out to a healthcare facility down in southern Illinois, and the reason we were there was comfort issues. This was a brand new building, probably wasn't even 2 years old when we came and looked at it. It's like, this is a 2-year-old building, why are we being called in to look at it? And so something that we identified is, looking at this window, here's the normal photograph, and then we have our infrared image here. So you can see, here you got double pane, thermally broken glass, very well done. They forgot and didn't order thermally broken sashes. And so, the window's okay, but all the metal in there is just leaking heat like crazy. And on the picture on the right there, you can see here's a wall section. You can even identify there's a fastener, there's a fastener, there's a fastener. So you can even see what the nailing pattern and everything was just because of that thermal bridging. The insulation's really good, but you have all these thermal bridges. So this is why that really plays a role, is making sure that the details are right. And, again, you get a window that's good, and then you end up missing something in between. Another path that they allow for, another option for compliance for prescriptive, is reduced air infiltration. So here we are going to pressure test the building envelope. Sean's got all kinds of stories from other locations that he's been to that building envelope failures, just, they didn't finish the envelope. But it was above the ceiling, so no one noticed. And all the havoc that caused with all the HVAC systems that couldn't keep up because there was a giant hole in the outside. And so doing this, the code for compliance for a pressure barrier for commercial buildings has 2 paths you can take. One is do a pressure test and actually verify it. And the second is use a list, use materials that are on this list of, I believe, 13 different materials, one of which is, I believe, 1/2-inch drywall. Okay, yeah, I can put in 1/2-inch drywall, but did I actually seal it correctly? Did I install it correctly? I can use the right products and use them wrong. So with this, it's saying, do your pressure test, and the air leakage in this case is 0.25 CFM per square foot of envelope area. I believe it's under the normal testing method, it's 0.4. If you do compliance via pressure testing. And you're noting for exceptionally large buildings, over 250,000 square feet, you do have the ability to test the building in sections, but at least 1/4 of the building must be tested in any given test. So that can be good potential there. And here again, there's another, some more of this information out of Canada as far as how does the wind impact the mechanical systems, and what is the profile as far as pressure on the boundary. The 3 different effects all add up to give you a pressure effect. So that comes out of this document here. Again, they're looking at air leakage this time. The previous document was looking at insulation techniques. So again, that's where some of this 2015 success with the IECC book comes into play, is there's a lot of diagrams and things about how do you actually, what is the detailing that's supposed to be at those junctions? Because most of the time, that's where we're going to fail, is at a junction. Whether it's two light materials coming to a corner, or two different materials either coming to a corner or that transition between those. That's when most of the issues are going to show up. As far as building thermal envelope compliance, there's a couple of different ways for compliance. Probably most people are familiar with the R value compliance. We don't use the U factor as much here in this, here in the States, or we'll use the component performance alternative. This is the UA factor. So this is what ComCheck and ResCheck is. They are prescriptive path compliance methods. They are not a performance path method. So here's a look at the R value, section of the table based on where we are here in the state of Illinois, sections 4 and 5. So if you're under the prescriptive method, then you have to use at least this R value. For the commercial side, insulation entirely above deck is 30 continuous insulation, R30. So for a lot of roofs, that's going to be on the order of 5 or so inches, depending on what type of insulation they're using. And we noted earlier, we'll talk about it again later, as far as when you're doing renovations, you don't have to touch other building materials other than what you are working on. So like that roof, I don't necessarily have to raise all my equipment up because the equipment is not part of my project. It is the roofing. And we'll talk a little bit more about that later. Again, this is a prescriptive table. Thermal envelope as well as fenestration. So U factor, generally speaking, is the inverse of R value. So an R3 is going to be about a 0.33 U value on the order of. So again, this is prescriptive.
One thing to note on the assembly U factors, that accounts for framing and stuff in there. So if you do the 1/over conversion from R value, your U value is going to be a little bit different, and that's because it's accounting for studs and framing and things like that.
This can be, this U factor table, when you get into the residential side, this U factor may be a much better way to comply when you end up with flat roofs on residential. Because residential does not have this classification of insulation entirely above roof deck, and so it requires R49 versus R30 continuous for the commercial side. So that's where these U tables might come in handy in that particular instance. Noted earlier that the component performance alternative, this is what ComCheck is using. So they're doing a component performance. It also automatically factors in as the tables as far as air films and things like that. The code does call out that if you are using an insulated siding product, typically they will add the air film to the insulation value as part of their testing, because they're testing it with the air film. And so the code calls out you need to subtract that air film when you do that. When you put it in here. So, again, you're getting into the fine details there. So, with the changes, I think we'll turn it over. So, I'll let Sean talk a little bit more about some of the more specific changes in the 2018 code cycle.
So previously, with slab insulation, you heated slab, you'd do perimeter insulation and then horizontally underneath to a certain depth. Now it's fully insulated under the slab. So that's what this is calling out for heated slabs specifically. For unheated slabs, you can still use just the insulation under the perimeter of that slab and along your exterior perimeter. Again, one of the things I'd like to point out through this, the thermal break between the interior slab and the exterior concrete wall. A lot of details. Some contractors, especially for crawl spaces, slab on grade, your insulation will be on the interior face of this wall. It will have angled insulation. You have a thin, easily crackable concrete slab along the perimeter. So this is one detail that can kind of avoid that. You have essentially a floating slab. There are other methods using exterior insulation to get the same thermal break. For combustion appliances, C402.5.3 in the code specifies minimum construction methods for rooms containing open combustion appliances. So that room has to essentially be treated as an exterior space. The perimeter of it has to be insulated, has to be isolated from the conditioned parts of the building. One way to avoid having to do that extra work, use a high efficiency sealed combustion appliance. You don't have to worry about having open ventilation into a combustion air zone.
Now this we don't have to do in the state of Illinois, but something to think about. If you're bringing outside air into that thermal envelope, this is going to be a potential weak point, of a building system and potential malfunction. So that is one detail that we do call out. It is in the code, but Illinois has amended that piece out just due to the cost of constructing these thermally isolated rooms.
For HVAC section 403.26.1, airflow minimums for VAV boxes have been reduced from 30% to 20%. If you're looking at this diagram, it's your reheat and cooling. There's a section there in the middle where you're cooling the air and then having to heat it back up to keep people comfortable in the space. You're cooling the air for humidity control, but then it's too cold to your space around 65 degrees if you don't warm it back up. So these reductions to your minimum VAV airflows are just minimizing that simultaneous heating and cooling as much as possible. Vestibule heating, maximum heating temperature is 60 degrees Fahrenheit, and that heating is only being enabled when outdoor air temperature is less than 45 degrees. Vestibules should be conditioned to interior temperatures. We're kind of getting away from that because that vestibule there has an air break between outside and inside. It's not necessarily a conditioned occupied space. There's no reason to dump all the energy into it to keep it at occupied temperatures. So this code is calling out that space doesn't necessarily have to be conditioned at occupied levels. You can save a lot of energy in those spaces by simply letting them coast a little bit more. So that's a change for vestibules in this version of the code. Storage water heaters. Heat traps are now required for hot water storage tanks, not just water heaters. And the heat trap is just this little piping loop, keeps you from having convective water flow due to differential temperature of the water. And that is a change for plumbers. The plumbing code, I don't think, includes this in it. So it's something the energy code adds on top of the plumbing code. So that's something to be aware of for plumbing contractors, is that if they're following the plumbing code, they'll also have to reference the energy code to know that to install these. Lighting levels. C405.2 allows for lighting controls to take the place of centralized controls. Instead of having timers on systems or a central automation system to independently control your lighting, lighting can have built-in occupancy sensors on each fixture. You also must include an occupancy sensor and an ambient light sensor and wireless reprogrammability so that these things can be set up independently. Occupancy sensors are now required in more spaces. A big change. Open office areas are now required to have occupancy sensors. Warehouse storage areas also are added into that over the 2015 code.
And it should be in each fixture?
Occupancy control, it's a set area, I think 600 square feet for open office plan. It has to be under a sensor's control. It doesn't have to be per fixture, but there has to be some control for space. But previously, open office plans like cubicle areas weren't included in that because they didn't want lights turning off on the whole area if someone was in the back of the room. So they've broken it up and required a sensor per so many square feet. I think it's 600 square feet. So those are the additions on the lighting sensor requirements for lighting. Everything else is the same as the 2015 code: classrooms, conference rooms, spaces with fluctuating occupancy. This is an example of open office area lighting sensor. You can imagine if you had some lighting sensing control over by the light switch and someone was over here in the corner, they'd be a little annoyed by the light shutting off on them while they're trying to work. So open office plans in the past were exempt for that reason. Now they're just broken up into small sections so that each section can be controlled. Daylight responsive exception. Daylight responsive controls are not required on perimeter lighting if that wattage is 40% lower than the allowance on a weighted average. The office allowance is 0.79 watts per square foot. The threshold for daylight responsiveness controls, if you take the 40% off, is 0.47 watts per square foot. Does anyone know why they picked that 40% level? Primarily because with LED lighting and things like that, if you install lower wattage, lower power density on the perimeter of the building, the savings for putting in daylight harvesting controls there is about 40%. So if you can reduce the perimeter by 40%, then you don't need that lighting control there to get your 40% savings. So that's why that's in there. The rest is just an example of a breakout calculation of that. It's an example of why that 40% is selected for an exemption for perimeter lighting, daylight.
So here you can see, here, as long as my total installed power for lighting for the building is under 126,000, I'm done with daylight harvesting controls. I don't have to buy them, I don't have to install them, I don't have to maintain them, and I don't have to commission them. So that's where it's just a weighted average across the whole building. It doesn't necessarily mean you have to reduce 40% in that specific area. You can do it across your whole building. So in this example, I just have to be 20% less because my daylit area is only half of my total square footage. So it's a weighted area average.
When do you have to put the daylight harvesting?
If you have over 150 watts in the daylit zone, whether that's the top lit zone or the side lit zone.
Is that in every building, or is it just offices, or what?
This is in the code. I believe it's all buildings with some certain exceptions. They do have certain exceptions in the code as far as I know for large manufacturing. There's a couple of assembly areas, and then there's a few other areas in the code that exclude them. But generally speaking, if you're over 150 watts in the daylit zone in a commercial building, daylight harvesting is required. So there again, this is why I highly encourage, rarely in the code do I say, I love an exception. This is one exception to that. Because make use of this and make everyone's life simpler.
I'm a big fan of limiting the complexity of controls because in my experience, I've done 3 years of continuous commissioning on site and facilities. I see a lot of time to put in a super complex system to get efficiency, and within a year, half the sensors are out of calibration, the building's using 3 times more energy than it ever should have in the first place. So anything you can do to simplify and limit controlling, we'll like it. Interior or exterior lighting controls. Daylight shutoff, something that's been common on lighting for a while. Time switch control functionality. Decorative lighting shutoff during non-business hours was not part of the code previously. It's now part of the code. And lighting setbacks, like parking lot lighting, if there's an occupancy sensor out there to dim the lights down if no one's driving in the parking lot, it's not part of the code.
Previously, it was either daylight harvesting or time clock control for exterior lighting. Now it has to have both. So
Back to that last slide, so you have to have a high-low on your exterior lights.
you are required to have daylight shut off and time switch control. The 30% setback, that can be either dimming, that can be selected fixtures. So you could say, okay, I've got a larger parking lot out in front of the building. The ones further away, I'm going to go ahead and turn off. And the ones closer in, I'm going to leave on over all the time. And they do call out when this specifically has to happen. And they give you a couple of different options for that, whether it's from midnight to 6, 1 hour after close of business to 1 hour before the open of business. So there's a few different options in there, similar to that decorative lighting shut-off. The lighting setback has similar criteria as far as when that can happen. This may be an area where it might be a good idea to look at local zoning ordinances and perhaps incorporate this in. Because if you have a new business move in and they have to do this, and the one next door is a legacy business that doesn't, you could have a competitive disadvantage for new businesses moving in. Now, it doesn't necessarily have to be, yes, all businesses need to comply tomorrow, but incorporating in, hey, over the next 10 years, we need to build this functionality in. So that is one where, as codes change, you can run into some challenges there. So, but this doesn't necessarily say this has to be done in one control system. So you could have a daylight shut-off photo control in series with the time switch control. So you can have two separate controls provided. It just has both functions have to be there.
Track lighting, there's just been a demand reduction in the watts per square, or watts per linear foot for track lighting. It's been reduced to 30, from 30 to 8 watts per square foot. Again, the big driver for that is the popularity of LED lighting. It's a lot easier to bring that track lighting wattage down. Reduced lighting power allowances in office buildings. The space by spacement area. The office space building area method has been reduced from 0.82 to 0.79, the 4% reduction. Libraries have gone through a much larger, more significant reduction. Again, LED lighting makes it a lot easier, especially when you've got track lighting to highlight rows of books, things like that, that typically in the past kept library lighting power higher. With LED lighting, as it's new technology, it's easier to bring that power density down, so they've incorporated that into the code. Increased efficiency requirements for transformers and motors. These are, for transformers, one thing to be aware of. Can you tell the difference between those two? One's a high efficiency, one's a low efficiency. You just got to look at the nameplate on it. Motors, they're moving more towards permanent magnet motors and electrically commutated motors. The technology has improved. Those motors are now available in larger sizes. So again, driving the efficiency improvements from the industry itself.
For transformers, that's now the DOE 2016 is the minimum standard, and motors is NEMA premium, is minimum efficiency.
I don't think you could have bought one that wasn't 2016 in recent years. Anyway.
We won't say they're not manufactured. Someone doesn't have one sitting on a shelf somewhere. But yes, it's what you do see is throughout the code, the minimum standards on a lot of this has become the commercial industry standard. But there's something out there to check is to say, if you go by, it's like, hey, this transformer really putting off a lot of heat. We need to check the efficiency on this transformer. Did you put in one that was not putting off?
For renewable energy, this applies more towards the performance path. Only 5% of renewable energy credits can be attributed to the performance path, reducing your building energy consumption. What they're trying to avoid here is having a high consumption building that you're offsetting with renewable energy. They're trying to drive efficiency of the building first and then supplement with renewables. So that's why this is part of the code, limiting how much of your renewables can be applied towards energy reduction on your facility. And now requires the building owner manual to be provided to the building owner. Previously, it wasn't part of the code. The usability of this is what's in question. I know I've been in facilities where shelves and shelves and shelves of owner manuals and install manuals, and they've got 3 inches of dust on them. It's one of those things where they're trying to get people to start using those to maintain their facilities better and maintain long-term efficiency. But the client actually has to do it themselves. So the code is trying to facilitate that through the requirement that those materials be provided to the client.
They do require that O&M be provided as far as what O&M has to be done for it, and as part of that listing of, things like you have to change the belts on the air handler every 6 months. Well, you have to tell me where I need to go in this documentation to find what that belt is. You have to tell me that I need to change it, and then where do I go find it? So that's something. Enforcement of this is going to be extremely difficult because this is within 90 days of the certificate of occupancy. We understand that once the code official is giving you your certificate of occupancy, that's the end of their interaction. So really, unfortunately, the only enforcement mechanism for this is training of the building owner ahead of time, saying, be looking for this. They are required to provide you this documentation, be looking for it, and if you don't get it, go back to your design team and say, where is it? So it's not a great enforcement mechanism, but at least the code is recognizing this is important, because if we aren't able to maintain a building, then all our bells and whistles are going to be gone. And it is not uncommon to see the newer a building is, the more energy it uses per square foot, which is backwards from what the model codes are telling us should be happening. And a lot of that goes back to we're not able to maintain these. We try to fix stuff by putting more gizmos and gadgets in rather than fixing the problem to start with.
I don't know if it was in ASHRAE 90.1 or a white paper, but somewhere there was a recommendation or requirement that could meet that part of the code if you put a nameplate on the equipment that included the O&M documentation, like this size belt gets on this area. So that could be a means to meeting that, just requiring a nameplate or a maintenance plate be added near the equipment that includes O&M information.
We on another project that I'm a part of, we do assessments of some industrial facilities. One facility we visited, it was amazing because right next to, and right on the pedestal of basically every motor, they would tell you the type of lubricant and the frequency and the quantity that was required. And so it's real easy for people to walk up and know, oh, I know I've got to grease the motor. Okay, what type of grease and how much do I need to put in? Because if you over-grease, you're going to destroy it. Similar to under-greasing. So that was one that, and at that facility, we looked at it and we're like, this is highly unusual. How did you think to do this? And B, how did you get it done? I said, well, we have commonly seen problems of over and under greasing things. And so we knew this was a need. So they actually took one of their employees who unfortunately went off on light duty, or had gone out on workman's comp. they were able to bring him back on light duty, and so that was his task was go find in the O&Ms for each one, what is it, and then take this little engraving machine, engrave a little plaque, and mount it. And so that was the way that they were able to bring someone back and make them useful and get some good data for that. One of those that, again, best practice versus what we end up with in reality. So, as far as moving over to the residential side, so that's kind of the high points as far as the commercial side of things. I will note again about, because this is found in both residential and commercial, that definition of approved. Previously, it was acceptable to the code official based on testing by the code official or a national testing laboratory. The new 2018 version is acceptable to the code official, period. So that gives code officials a lot more ability to look at situations, because we understand that, it's not uncommon where you'll end up finding a disconnect between code and reality. Where it's like, I want to do something, but I have this condition that really doesn't allow me to do that. So by changing that definition of approved, it allows a little better, a little more leeway and flexibility for the code officials to look and say, are you meeting the objective? So I think we might talk a little bit about one example that we've worked through with some code officials in the past is garage conversions. It says I have to insulate the slab. Well, how do I do that for an existing garage converted into living space? It says I got to have an R5 or an R10 around the perimeter. The slab's already there. What do I dig around the whole foundation and dig up the driveway that goes all the way up to it? How do I do that? So what we ended up talking back and forth with is say, okay, what if you put the R10 across the whole slab instead of insulating the perimeter of it? So that was one of those that we kind of had to get a little creative and say, can I get something that performs at least as well as what the code calls for? Because I don't have a perfect situation. So that's one that having some of that flexibility of saying, am I meeting the objective? So as far as residential, there's a couple of different compliance paths. First is our prescriptive path, which is our sections 401 through 404 that we talked about earlier. Number 2 is simulated performance path. So this would be using certain software packages. This is not ResCheck. ResCheck is a compliance path 1. Simulated performance, that might be a train trace, an eQuest, any number of the DOE energy modeling softwares. And then the third is the ERI, the Energy Rating Index, close cousin of the former ResNet. And then we call out here, there are mandatory requirements in 401 through 404. Those have to be met regardless of which one of the 3 compliance paths you're using. On the residential side, there's a lot less mandatory than there is in the commercial side. So, air barrier, again, the code is really noting, identified that the biggest thing with air barriers is making sure continuity, and that they are continuous air barriers. And so, trying to clean up some of this wording, again, in 2018, they added continuous manner to really, hit home the part that this air barrier's got to be continuous. You put a little hole in, and it's amazing how much air can fit through a 1-inch hole or even just a little 1/8-inch gap around the electrical box. Air leakage requirements. This is one where Illinois has amendments on this. Formerly, in the 2015 version, it was 5 air changes per hour. They are now moving to 4 air changes per hour for this code cycle in 2018. It is anticipated that for the 2021 code, they will remove their amendment and we will go to 3. So the energy code, a few code cycles ago, in that dramatic change in the residential energy performance, they went from 7 interchanges to 3. And that was about the same time as Illinois adopted the energy code. And so it went from, we didn't have an energy code, to you now have to have 3 interchanges per hour. So everyone's like, whoa, this is a really big learning curve. So Illinois went and said, okay, we're now going from nothing to 5, we're now moving to 4, and in the future we're going to go to 3. So as contractors have been able to go along that learning curve as far as, where are the weak points? How do I treat those and get better? 3 is not an uncommon level to reach now. So, but now saying 4. Another Illinois amendment is whole house mechanical ventilation. This doesn't necessarily require an energy recovery ventilator or heat recovery ventilator, but that you must have mechanical ventilation. Because, again, we tightened up the envelope and we want to properly ventilate. We're trying to get away from the house needs to breathe. Well, I don't want to rely on the direction and speed of the wind to breathe. So I want the home to be ventilated regardless of the outside conditions. So noting that we need to make sure that we do ventilation. We don't want to end up with sick building syndrome that the commercial side had. So I also note that there is some exceptions when you're doing additions and alterations as far as testing. You don't necessarily have to test a building envelope, because if I do a renovation or an addition to this building that's over 100 years old, I'm never going to get the envelope to pass. No matter what I do in that addition, just the existing envelope will not pass. So it's saying you don't have to do the air barrier test, but you do have to make sure that you seal it correctly. So this one, it's going to be going to end up being a lot more detailed for the code officials as far as inspections. And did we did we get that air sealing that happened?
This is actually a weak point that I've seen out in the field. Additions to buildings, especially with masonry walls where you've got that air gap behind your brick. A lot of times the addition will be built on and that air gap gets left there. And you've got an open hole along the entire wall with outside air in it. They had an elementary school that had that problem. They just had dehumidifiers running in the classrooms on that addition to take care of the additional air flow. So that's where this comes in to be a really important addition to the code.
Not a lot of changes here. A little bit improved on fenestration. A little bit here. 0.35 to 0.32 or 0.32 to 0.30. Again, manufacturers are getting a little bit better at making windows and making them more cost effective. So cost effective, we moved forward a little bit in code. We'll call out there is an Illinois amendment to this table here, called out in blue. So noting here, Illinois has modified this table just slightly so that zones 4 and 5 match each other. Probably have all seen this fenestration label as far as it's looking at the U factor and the solar heat gain are the two things called out for in the code. This is one of the weak points for replacement windows that we see. Normally new construction, this is generally not an issue. It's on replacement fenestration. I don't know, how many of you require permits for replacement windows yet? Okay, some, all right. Which this is where we generally find a lot of the issues. Because most of the time when you just walk into the store, everything on the shelf generally fits, or generally meets the guideline, but it's not uncommon where people will go to the store and find, oh, hey, there's this utility window that's cheaper. I'll buy that one. Without realizing what are they doing to their solar heat gain coefficient. Again, this is where it becomes a comfort issue here. Again, windows today are getting better and better. I will note that there was previously an amendment to this table for solar heat gain coefficient. That has been removed in the 2018 version. It moved the 0.4 in zone 4. It removed that and said there was no requirement for solar heat gain. But again, most every window manufactured today meets a 0.4 already, so having that didn't really do anything. That is something else that Illinois has been trying to do. As each version of the code, they're trying to remove some of the amendments that they had seen previously, just from the aspect of building trades have gotten better. And so it's not uncommon where requirements that were once there really have no purpose anymore. As far as ducts in the conditioned space, how do we determine if a duct is in the conditioned space? Particularly for if you're doing some energy modeling. And so it calls out 3 criteria as far as, obviously, if it's totally inside the air barrier, it's totally in the conditioned space. Or if it's buried in the insulation and it has these criteria. Normal duct leakage, you're allowed 3 CFM per 100 square foot. So these have to be much, half the air leakage rate or less than a typical duct, and then obviously your insulation. Fan efficiency, I don't know how frequently we run into too many issues with this, with HRVs and ERVs. How many of you are seeing these installed as part of normal practice in residential yet? Not really. Okay. These tend to be a more premium product. But we do call out there is a fan efficiency requirement. And again, it's because this is running 24/7. So any efficiency gain here is really going to be beneficial. I think probably a lot of people just see a continuous, for lack of a better term, bathroom exhaust fan, and then a duct cut in to bring in the fresh air. One of the challenges with that goes back to that building pressure, where these are very good about balancing that supply of exhaust air. If you don't, you can end up with building pressurization and sucking in unconditioned air in places you don't want it. So, one of those best practice versus reality things. This is what one of those looks like. Something else that this can also provide some benefit to is if anyone does sealed crawl spaces, is this HRV or ERV can pull the air from the crawl space to exhaust and use that as my exhaust air leaving the building. So my crawl space will actually be a little bit negative to the house, and air will flow from the house through the crawl space and then out. So that is something that we have seen before is if you seal the crawl space well, then if any moisture gets in there, it gets kind of stale and stagnant and things aren't good. So an HRV or ERV can provide some benefit by using that crawl space as a negative exhaust and pulling that air out.
It's a lot better than the common practice I've found where they cut a hole in the return duct and then on the far side of the crawl space they just drop a supply in. And then you're pulling that nasty crawl space air into your return and blowing it through the whole house.
The other big change for residential, as we've seen in one of the earlier charts, residential lighting is a big one. So high efficacy lighting is now required in 90% used to be 75% of fixtures now have to be high efficacy lighting. We'll also call out there is an Illinois amendment to this as well, as far as definition of what high efficacy is. For Illinois, it is 65 lumens per watt for a bulb or a lamp, and 55 lumens per watt for a fixture. Now, when we did a market sample of what's on the store shelves, about 85% of everything met that higher threshold. And surprisingly, it was the more expensive stuff that didn't. The cheaper building grade stuff met the requirement. So it's only when you get into these fancy fixtures that they end up failing. But the other big change here is they have eliminated an exception. It's easy to see in a code when they add text. It's a lot harder to see when they remove it. They removed the exception for low voltage lighting. So now all that track lighting that used to be, oh, I just put it on low voltage and it doesn't count towards my 75%. It doesn't count towards my 25% allowance. Now it all counts. So. Now that 10% still allows you some accent lighting and things like that, but say, really guys, high efficacy lighting is readily available, and there's 7,000 options on the market now. Surely something will meet the need. So you can have your specialty lighting, or if you need that full dimming capability for a media space, go for it. There's some room there. Performance, if you've got multifamily, they do now allow batch sampling. So rather than having to run a model for every single unit that you're building, you can run one model and use it for multiple units, as long as they are the same. So same footprint, same direction facing, same exposure, as long as they're allowed, or as long as it's very the same, you only have to run one model for the performance. Something else that Illinois is also doing, mentioned earlier about the 4 air changes per hour. Illinois is also going to allow for residential you to do to use a volume or use a surface area metric. So very similar to the commercial side where it's so many CFM per square foot of surface, Illinois is going to allow that for residential as well. The reason being is when you get into smaller units, well, your volume to surface area ratio gets out of whack. And really, what is the objective here? We want a tight envelope. Well, if I make a really big house with a relatively small envelope, well, my envelope can leak a lot. So they're looking at saying, really, we want a tight envelope, we want you to test and prove a tight envelope, not just did it leak so much volume. Noted earlier about this energy rating index, this is one area of the code that it went dramatically up. You are allowed to use substantially more energy in the 2018 version than in the 2015 version. And this is primarily because they were not seeing a lot of people taking the ERI path before, or the HERS rating. So this is them trying to drive to encourage the HERS rating versus other performance methods. We will call out again the existing buildings. So here noting, if you do have additions and alterations, you don't have to change existing structure if that is not part of the project. So now if I open a wall, I must fill the cavity with insulation. And noting down here for masonry, I want to make sure I leave an air gap behind that so that the masonry, because masonry does wick moisture. I need to make sure that I have a moisture break between the inside and outside. So that air gap is very important for masonry. So do say, leave that air gap, but as long as you have, if you open up a wall and it's a 2x4 wall, code says I need an R20 insulation. I can't fit R20 in a 2x4. But as long as I put 2x4 insulation in that wall, I'm done for code compliance. Now, if I'm going to fur that wall out, then yes, I do have to bring it up. But if it's existing, just fill the cavity and bring it. If you do have a building that's over the 30% or 40%, depending on which provision you're under, if you're over that 30% limit, you're allowed to keep it. But the new windows must meet the same U value and solar heat gain coefficient. So, we'll see that on a lot of places where warehouses are changed to flats. And so the warehouse had all these giant windows. Well, you're allowed to keep that excessive fenestration area, but the new windows have to conform. Mentioned earlier about roofs. Where we run into issues with that is, existing low slope roofs might have only an R5 insulation on them. Well, when you go to tear the roof off, and the code says put an R30 back, well, I had 1 inch, and you say I need 5. Well, I may have an issue with flashings or curves, parapet walls, equipment, platforms, and the like. That might say, I only have enough room for 3 inches, so I can only put an R18 in here. Well, that's fine. The code says, give me the R18 because that is the best you can do without requiring you to alter the rest of the roof. So, but you have to do the best you can with what you have given the existing constraint. So that's one that frequently we see that a lot. With that, I'm going to turn over to Cassie here. We will answer questions here at the end. And after Cassie presents, I do want to ask one question as far as what is the biggest challenge that you guys are seeing or are facing as far as energy code compliance? As we had seen earlier, when that sample of 69 code officials said, well, it's a lack of knowledge on building professionals. We realize that's a skewed sample. So that's where, because we actually have I think, a fairly broad sample of design professionals, code officials, maybe even not sure if we have any building owners here today, but we'd like to get a better representation and find out what are the issues. So we, as the technical resource for you all and everyone you deal with, we want to try to do that and figure out how we can identify where the pitfalls are and how we can address those.
Awesome. Well, thank you. So thank you very much. I'm going to turn it back over to Ryan.
Going back to the question earlier, real quick, looks like I got about 5 minutes here. As far as what challenges are you seeing as far as energy code compliance? What are barriers? Other suggestions for outreach and improvement. What are you seeing as your biggest challenge?
Education is definitely a challenge for our local contractors and design professionals. Design professionals are catching up, but it's still a learning curve.
Sure. Okay.
Mostly it's the interpretation of that code. It's really hard to read it through it. Sometimes it's like telling you go to that section and then to that section. Lack of examples, there's no individual examples is
Sure.
really helpful.
Okay.
And sometimes it uses very hard English language that a regular person when it reads it's not that easy.
Yeah, reading code language is definitely a specialty skill. It's not your regular reading. So,
Right.
yeah.
That supplementary code book can help a lot with understanding some of those sections.
Yeah, the code does offer there is a commentary edition, which does provide some additional details. Also, again, this is one benefit that we're trying to help reach out to other areas, particularly areas of the state that have not really, been reached out to as far as, focusing and allowing people to know, hey, we are here to help. So yeah, if you do run into certain situations or questions, feel free to reach out to us. And yeah, we're here to help, not only code officials, design professionals, building owners. Occasionally we'll even get calls from some homeowners that are really excited and enthusiastic and have some knowledge, and they're like, okay, how do I do this better, and what is, we love answering questions and helping with some of that, so that's good.
I know one of our problems as a design engineer, but the inconsistency of the codes. If you have to follow the 2018 IECC, but you're in a community that's got, wants you to use Boca 1996 for the mechanical system.
Sure.
You can't, it just it becomes awkward.
Okay. Yeah, the intricacies of different locales and what their local building codes are. That is something that we have looked at, and actually that brings up a good point as far as one benefit that we have seen from the energy code standpoint is it doesn't have, we don't see too many areas where you end up with a conflict between the energy code and a building code. One exception that we have found, and I haven't looked back too far, but we did note that with the, I want to say it's 2009 version of the I-codes, the vapor barrier moved. It used to be in the energy code, and starting with the 2009 building codes, it moved from the energy code to the building code. So if you're in a jurisdiction that is pre-2009 building codes, there is a potential of a missing vapor barrier because it's not in the energy code anymore, and it wasn't in the building codes at that time. So that is definitely one of those. So yeah, that's a good point there. Other challenges that you guys are seeing?
Yeah, I'm building inspector for Freeport, and I work in Stevenson County. Doesn't really have any kind of inspectors, or they don't really follow up on their codes. So I get contractors that work out in the county, and then they come into the city, and they're, well, you're being way more restrictive. I just built a house on the county, and we didn't have to do X, Y, and Z, and I didn't have to do all this stuff. So I kind of get a lot of pushback from contractors being defined and different things, and adds more cost onto their project. Issues like that.
Okay. Yeah. I guess that goes back to consistency of enforcement. Because there is a little bit of a nuance in the administrative code as far as if you're in a jurisdiction that doesn't have building permits, this doesn't apply. Which, that to us is kind of a giant
hole.
A giant hole that you look at and you say, again, the energy code, it's focused on energy, but because of the detailing like continuous insulation, the air barrier, the things like that, this deals with building health, building comfort, and building performance. That because if I don't put in the vapor barrier, and I don't have ventilation, I can real easily end up with a mold problem. And so now I got a mold issue in the home, and that's not good. So, other challenges that you guys are seeing out there in the field, as far as adoption or other? So,
I think enforcement is an issue too, and in our Rock area we had a regional group of different code officials who got together to try to all adopt 2015 at the same time, try to limit as many amendments as possible. So we've got a lot of things on the same page, but we find that when it comes to energy code, we enforce a lot more than some of our other cohorts around the area. I don't know, just from, again, education, understanding, or just choosing that to enforce energy code.
Yeah. Which, that you bring up an excellent best practice. It's something you guys have done, and I know Peoria County and a couple of others around then, where they said, okay guys, everyone in our region, we're going to move to a regional basis, and I think on theirs they've decided we're going to move codes every 6 years. We're going to skip intermediate code cycles. We're going to move every other code so that way everyone can get on board. I know originally they did have a lot of pushback, and I don't know if your experience was the same, that once contractors figured out, wait, I'm only going to have to use one set of code books? Yeah, I would, is it going to be a little bit trickier to, implement that code? Sure, it's going to be a little bit more stringent, but I gain on the efficiency of, I only have one rule. I don't have to worry about, well, if I'm over here, it's this rule, and if I'm over there, it's this rule. I know in a lot of counties, particularly on the electric side, 3, 4, 5 different codes depending on which spot in the county you are. From someone working on this, that's a nightmare. So, yeah, that's actually really good practice to get in. So, okay, all right. Well, I do want to thank everyone today. If you guys do have any questions on the code itself, we'll be after here, or reach out to us, energycode@sedac.org.